This is Cynthia Sue Larson with RealityShifters.com, and I'm the author of the best-selling book Quantum Jumps, which is the extraordinary science of happiness and prosperity. Today, I'm planning to talk to you about something pretty exciting, and you may have heard about it on the news. It has to do with the discovery that was made by the BICEP2 telescope, which is located in Antarctica, where it can easily, or more easily, be able to take a look back to the beginning of the Big Bang and the universe, or that was the goal, to look as far back to see what were the original imprints from that Big Bang in terms of the polarization of what's known as gravity waves. So I'm going to back up a little bit and tell you what that BICEP2 telescope is all about. BICEP stands for Background Imaging of Cosmic Extragalactic Polarization. And the polarization in question has to do with the way that light is affected or influenced by gravity. And so this is a very kind of a tiny diagram here, but you can see if you wear polarized filters on your sunglasses, then you benefit from blocking light from coming in at certain angles. So it just comes in along the lines that your glasses are polarized in. And along the similar kind of reasoning, physicists were taking a look to see if they could track and see polarization patterns caused by gravitation waves. And the gravitation waves they're looking for, that's this other picture here. If you look at this time of inflation, which was theorized and speculated about, which would be following the Big Bang, and that inflationary period is a time when everything came from something so small in such a big flash and a big explosion of energy by as yet unknown means, which are open to theorists' conjecture at this point and hypotheses. But that huge explosion and inflationary period contributed to this idea of a time when everything was, if it was really expanding that fast, there should be some kind of a steadiness or constancy perhaps to it. That was the theory, and this, you could think of it as kind of an opaque time period where you can't really see through what was going on at this time period because the electrons and protons were being scattered by that gravitational influence. And this is what Einstein had expected as well. Now I've got another picture which hopefully is going to describe it a little bit better. You can see at that time of the Big Bang, the big flash, that we can't really look back and see it very clearly because we're blocked by this time period of this what you might call quantum gravity era. And that's this time period of rapid, super rapid expansion when the background made radiation, that cosmic microwave background, CMB radiation, was found by the scientists working in the Antarctic at the BICEP2 telescope just this last month. They found that indeed there does look like there's strong evidence to suggest that there has been a tremendously fast inflationary period just following the Big Bang. What they're looking at is seeing evidence of polarized light that is evenly distributed throughout our universe, which in our universe has come from a subsequently smoother inflationary period from that time of super fast inflation at a rate that just boggles the mind, frankly. I mean, it's just hard to even contemplate how fast things were expanding, but it looks like it was at a rate of about 10 to the 16th. And so the energy subsequently and the frequency of those energy waves is much more powerful than anything we even have, such as at the Large Hadron Collider. So we're talking about 10 trillion times the peak energies that we even have here. And at those energy levels, all except the gravitational forces in physics, all three of the other forces, the strong, the weak, and the electromagnetic, were all operating as one. And so that's what this picture is showing, is that our very universe has evolved from this massively fast expansion. And that's where things get really exciting for me personally. I mentioned that I've written that book called Quantum Jumps, and the premise of the book is that we do live in a holographic multiverse. And what that means is that, and this research currently is starting to begin to support that this indeed is a multiverse because of the expansionary nature of the rapid beginning and the fact that new universes can spring up so easily. That's no longer pure theory, but now the multiverse is becoming explanation for some of the theories that are out there right now. And I find that super exciting because if we do live in the kind of holographic multiverse that I write about, that I talk about, then we're starting to see some confirmation of this scientifically in just the last month, actually, which some scientists thought we might never see in our lifetime. And because the evidence of this rapid inflation is now coming to light, all of the multiverse theories are gaining a great deal more ground, a lot more backing. So that means in the future, maybe 20 years or less from now, we might actually start getting some strong evidence of these otherwise just hitherto purely theoretical parallel universes outside our own. So I hope that gives you something to think about. Until next time, keep asking how good can it get. And this is Cynthia Sue Larson with RealityShifters.com. Thanks so much.